Okay, so now we're going to investigate a little further with multiplying radicals, and these ones are going to be a little bit more complicated than the ones that we started with the other day. And this one is going to be using radicals which contain an expression containing a radical with two terms in it, multiplied by another radical containing one term, or radicals that have two terms in them being multiplied. So if you look at how you do something like that, it kind of relates to what we did in 1201, which was using polynomials. When we have a monomial multiplied by a binomial, we use the distributive property, and that 2x there, for example, would become 2x times x, or 2x squared, plus the 2x get multiplied by the 1 to give you 2x. And if we have two binomials being multiplied by each other, the first term would have to get multiplied to both terms to give you 3x times 2x is 6x squared, and then 3x would get multiplied by the next term, which is 5, and that would give you 15x. And then you'd move to the other term in the first binomial and multiply that through, and that would give you minus 2x and minus 5. So that would give you 6x squared plus 13x. And you put the like terms together, 13x, right? And then minus 5. So we do pretty much the same thing with radicals, using those same ideas. So in this case, the first example here, if we're going to simplify this expression, we would distribute the 4 root 2, and that would give you 4 root 2 times 7 root 5 plus 4 root 2 times root 3. And if you use your rules for multiplying radicals, this becomes 28 root 10 plus 4 gets multiplied by what's understood to be 1 in front of that root 3. So that would become 4 root 6. And there's nothing more you can do with those radicals. That would be considered simplified, because root 10 cannot be simplified any further, and root 6 cannot be simplified any further. They don't have any perfect square factors. And they're not like radicals, so you can't add the 21 root 10 and the 4 root 6, so you just leave it in that form. The next one here requires using the distributive property twice. So we're going to distribute the 8 root 2, so it'd be 8 root 2 times 9 root 5. And then we're going to multiply the 8 root 2 by the 6 root 10. And then we're going to distribute that negative 5 to minus 5 times 9 root 5, and minus 5 times 6 root 10. Okay, so then your 8 and your 9 would get multiplied to give you 72, and the 2 root 2 and root 5 would give you root 10, plus in the next terms, you have 8 and 6 would get multiplied to give you 48 root 20. And the next one, you just multiply these numbers out front, give you 45 root 5. And the last one, the 5 and the 6, would get multiplied to give you 30 root 10. So right away I can see that this term here and this term here both have root 10s in them, so I'm going to subtract negative 30 subtract 30 root 10 from 72 root 10, because 72 root 10 minus 30 root 10 is going to be 42 root 10. And then while I'm at it, I'm going to break down the 20. Root 20 is 4 times 5. And then I can go 42 root 10 plus 48 times 2. Because the square root of 4 comes out of the 2, you're left with root 5. And then, I don't have a whole lot of space left here, but this would be 42 root 10 plus 96 root 5 minus 45 root 5, which would equal the 42 root 10. And then the 96 minus the 45 would be 51 root 5. Okay, so another couple of examples here to go through. So the next one we have would be two terms added inside the brackets and then squared. So that basically means when you square something, it means to multiply it by itself. So this would mean 5 root 3 plus 2 root 6 times 5 root 3 plus 2 root 6. And then you would do your distributive property. So the 5 root 3 would get multiplied by the 5 root 3 in the second expression. And then the 5 root 3 would get multiplied by the 2 root 6. And then you would basically distribute the 2 root 6 the same way. So the 2 root 6 would get multiplied by 5 root 3. And then the 2 root 6 would get multiplied by the 2 root 6 again. So that would give you 25. Now if we use our rule from the last section, a root 3 times root 3 is just going to give you root 9 or 3. And then you have 5 root 3 times 2 root 6 is going to give you 10 root 18. And then 2 root 6 times 5 root 3, you're going to multiply the outside numbers, is going to give you 10, and the inside number is going to give you root 18. And then the last one is going to be 2 root 6 times 2 root 6, sorry, it's going to be 4, not 2. That would be 2 times 2 is 4, and root 6 times root 6 is just going to be root 36 or 6. So that would be 75 plus, these are like radicals, so I'm just going to put them together as 20 root 18 for now. And then I've got plus 24. So now I know that the 75 and the 24 can go together and give you 99. And the 20 plus root 18 can break down because 18 has a perfect square factor of 9. So 9 times 2. And then that would equal 99 plus 20 times 3 can come out because square root of 9 comes out as a 3 root 2, which equals 99 plus 60 root 2, and that's as much as you can do with that one. So that's your final answer, because 60 root 2 can't be broken down any further, and it cannot be combined with the 99, because the 99 is just a whole number, and 60 root 2 is a radical. Alright, so see if I can squeeze D in here. So I'll just try to write a little bit small in the first line. So you'd multiply 3 root 8 would get multiplied by the first term in the second set of brackets. So 3 root 8 times 2 plus the 3 root 8 would get multiplied by the 7 root 3. And then minus 4 times 2. And then minus 4 times 7 root 3. Okay, I had to squeeze it in there, sorry about that. So this would be 3 and the 2 would get multiplied to give you 6 root 8. And then in the second term you've got the 3 and the 7 get multiplied to give you 21. And the 8 times the 3 under the root sign is 24. And you got minus 8 and then minus 28 root 3 for the last terms, because 4 times 7 is 28. And then 6 root 8, the root 8 can break down as 4 times 2, because 4 is a perfect square factor of 8. And then the 24 can break down as 4 times 6, because 4 is a perfect square factor of 24. And you have minus 8, and minus 28 root 3 can't break that down any further. It's a minus there. Okay, so this becomes 6 times 2 root 2 plus 21 times 2 root 6 minus 8 minus 28 root 3. And that becomes 12 root 2 plus 21 times 2 is 42 root 6 minus 8 minus 28 root 3. And those radicals are broken down as much as they can be, and none of them are like radicals, so you can leave it like that in terms of Some people might put all the radicals like first and then the -8 last, but there's not really any rule that says that you have to do that, so that's fine. Okay, so the last one here, I think again it's getting kind of cramped up here. You want to distribute the 5√6 to each of these 3 radicals inside the brackets. So that would become 5√6 times √3 plus 5√6 times 3√12 minus 5√6 times √2. Now again, I'm writing out every single step. If you can do that in your head, I can just come right to this step first. You can kind of skip that first step and write 5√18 plus 15√72 minus 5√12. If you can do that from here and kind of skip this step right here, go right to that, to the next step that I just wrote, the last step I just wrote down, that's fine. So now I'm going to break down 18 as 9 times 2. I'm going to break down the 72. Biggest perfect square factor of 72 is 36. And the biggest perfect square factor of 12 is 4. So then we've got 5 times 3 √2 plus 15 times 6 √2 minus 5 times 2 √3, which is going to be, and again, you can skip that last step I just wrote if you want to and go right to this step, if you can do that in your head from this step to the step I'm writing now. So 15 √2 plus 15 times 6 is 90 √2 minus 10 √3. And in this one, you do have 2 like radicals. Those are both √2s. So 15 plus 90 would be 105 √2 minus your 10 √3. And that would be your final answer, because the radicals are broken down as much as they can be. And no, there are no other like radicals that can go together. All right, so the next example here is just basically an application question involving multiplying radicals. So if you're looking for the area of this rectangle, area, if you remember, for a rectangle is length times width. So the area, and you're asked to find exact area, which means keep it in radical form, don't change those to decimals. So the length would be 5√6 plus √3 times the width would be 3 √3, but I'm just going to put the width in front because it just looks better. 3 √3 times 5√6 plus √3. Doesn't matter which order we multiply those, but it just looks easier when the 3 √3 is in front of that binomial term rather than after. All right. So then we're going to distribute the 3 √3, and that's going to give you 3 √3 times 5 √6. And again, if you can do that without multiplying, putting this step here, you can do that in your head. 3 √3 times √3. So if you want to go right to this step, 15 √18, you can kind of skip this step that we just wrote a minute ago if you want. And 3 √9 is actually going to be 3 times 3, because √3 times √3 is √9, which is 3. So then 18 can break down as 9 times 2. And 3 times 3 is 9. And then that becomes 15 times 3 √2. So all that's left inside. And that becomes 45 √2 plus 9. And there's nothing more we can do with that because the radical is broken down and 9 cannot be added to the 45 because the 45 has a radical part with it. And so there's some questions now listed down here that are in your textbook that you can try that will help practice some of this material.